Question number 13. At Dicey Dave's Diner, the dinner buffet usually costs $12.99. Once a month, Dave sponsors Lucky Buffet Night. On that night, each patron can either pay the usual price, $12.99, or roll two fair six-sided dice and pay a number of dollars equal to the product of the numbers showing on the two faces. The table shows the sample space of this random process. So if you roll a 1 on the first die and a 1 on the second die, the product is 1 and you pay $1 for your meal. But on the other hand, if you roll a 6 on the first die and a 6 on the second die, the product of those is 36, and now you're paying $36 for your meal. All right, part A. A customer decides to play Dave's Lucky Buffet game. Find the probability that the customer will pay less than the usual cost of the buffet. So what's the probability that we get a value, let's say that the cost is less than $12.99? All right, so we know that in our sample space there's 36 total outcomes, right? It's a 6x6 table. And we just need to count the values here that are less than $12.99. Okay, so all of those are under $12.99. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so 23 out of 36, which is equivalent to about 64%, 63.9. All right, part B. A group of 4 friends comes to Dicey Dave's Diner to play the Lucky Buffet game. Find the probability that all of these friends end up paying less than the usual cost of the buffet. Okay, so that's the probability that the first friend pays less and the second friend pays less, and the third friend pays less, and the fourth friend pays less. Okay, all of these are and. This is a long and probability. So to find the answer, we're just going to have to multiply, right? What's the probability that the first friend pays less times the probability that the second friend pays less times the probability that the third friend pays less times the probability that the fourth friend pays less. I don't know why I'm writing it as fractions because previously I wrote it as a decimal. Okay, so the probability that any patron, whether it's a friend or a non-friend, the probability that any patron pays less than the usual price is about 64%. Okay, and each outcome is independent. So whether or not the first patron or the first friend pays less is not going to affect the probability of the second friend paying more or less, right? Because the outcome is decided by dice, which are completely random. So basically this is 0.639 multiplied 4 consecutive times, which is the same as 0.639 raised to the 4th power, which is equivalent to about 16%, 16.7%. All right, you could also, do that problem by thinking about a tree diagram. So the first friend pays, pays more or pays less. The second friend pays more or less. The third friend pays more or less, and the fourth friend right? You get the idea, pays more or less. Even though this tree diagram would have many, many branches, we only care about one particular set of branches, right? And that's the set where the first friend, the second friend, the third friend, and the fourth friend all end up paying less. Now the value on each of these branches is 0.639. Okay, and so we would end up doing the same calculation, right? 0.639 raised to the fourth power. All right, part C. Find the probability that at least one of the four friends ends up paying more than the usual cost. Okay, so now I kind of wish I had drawn this a little bit neater. All right, let's kind of go back in here. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes. We know that there's only one outcome where all the friends pay less. Okay, and all of these other outcomes, the other 15 outcomes, have at least one person who's paying more. Okay, so in other words, right, these 15 outcomes would classify as at least one friend pays more. Okay, this outcome at the very bottom is the only one where everybody pays less, and that probability is 0.167. Okay, so there's a bunch of probabilities here, 15 of them. Right. And then remember that the total has to equal 1. Okay. So we can work backwards. We know the total is 100%. We know the probability of this one outcome, right, where everybody pays less. So if we just find the difference of these, then we'll know the probability of at least one friend paying more, right? We'll know the sum of these 15 probabilities. Okay. We're really using the complement rule here, right? The probability of at least one friend paying more is equal to 1 minus the probability that none of the friends end up paying more, right? So that's just 1 minus 0.167, which is 0.833, I think. Yeah, about 83%. All right. Again, I showed you with the formula, but I find it a lot more intuitive to think of it this way, right? As a tree diagram where there's only the one outcome where all the friends pay less, and all the other outcomes would qualify as at least one friend paying more, and you just do simple subtraction there.